Thank you all for inviting me. In this panel, I'm one of the foreigners, or the foreigner in the panel. So my accent is slightly different from yours. I won't have a French accent, although I can do it. I hope you can bear with me. I'd like to give a little bit of a look on a global scale on the EOR, but also a little bit what's driving the companies around the world to implement EOR technology and polymer technology. So I'm going to really talk about the technology in itself. So polymer flooding is a mature technology. We're running it at the moment in 350 projects around the world, and 150 projects are full field. And the other 200 are pilot projects. And some of them are ASP pilots, so there are no full field ASPs yet. Some of them, most of them are polymer floods, and some of them are another combination. And maybe just to also talk a little bit about the CO2 injection, we're now doing research on polymer and CO2 injection combined. So it's either a WAG, which is called polymer assisted WAG with CO2, or it is a blend. So that kind of technology is really in the research phase, but it's being researched right now, and I'm really, really excited about that, because one of the reasons I got into EOR is that, I want to make the most of what we have. If you have a nice pair of shoes, you resole your shoes. You don't throw them away and buy a new pair of shoes. So that's the way I look at oil fields, and that's my passion for EOR. And indeed, I started in 2000 in Shell as EOR project manager, and I haven't left the technology since. As you can see from the world map, the majority of the polymer projects, the volumes are in Asia, and the majority in Asia is in India. So Cairn, ONGC are major players in the global scale, and I really want you to understand that India and Oman are the two key countries when it comes down to EOR. And it's been perceived like that as well. So you can be a little bit proud on your own teams and your own technology and your own advancements of the technology with your own teams. So why use polymer EOR? Well, first thing, it improves the mobility ratio between water and oil. That's the big thing. And that's also how it started in the early days, but I'll show you later on that now we're also using it for lighter oil. The other thing is, and it was alluded to earlier, it's really easy to implement. It's modular. It can be done modular. It can be done in a central facility. It's cheap. It has become cheaper and cheaper. So the more polymer is being produced, economy of scale, the price has come down. When I started in 2000, the price of polymer was around $4 to $5, sometimes $8 per kilo. Now, I can give you a nice deal for $2 per kilo. But you have to come very early, be my best client, and then I can give you a nice price. The other thing is it's also sustainable, and I'll show you why. And of course, it's field proven. Mobility ratio, what we're trying to do, and this is for a heavy oil example, you try to get it as low as possible, so when you got a water when you inject the water, of course, it will go through your oil much faster and reach your producer. What you try to do is to match the viscosity of your oil with the viscosity of your injected water as much as you can. This also depends, of course, on your injectivity. So the first question I always get from all the clever reservoir engineers in the room is say, so what about Darcy's law? And I can say to that is that very often you under-inject, so you can go much more viscous than you are doing already. So this is for the heavy oil, but what we're seeing right now is a shift to lighter oils. So we're doing a lot of light oil projects, new projects these days, Kazakhstan, Middle East, and also South America. That means that the added value of the polymer is a little bit less, because you already have a reasonable good mobility ratio, but it also means you need less polymer. So economically speaking, it's actually a win-win. It's not for us because we don't sell that, the quantities are a little bit less, but from the system, the efficiency is actually a lot and it helps a lot. So as you all know, every decision in the end is an economic decision. You're not going to do something if you lose money on it. So for lighter oils, the quantities of polymer you're using are just less, but the effect is still economic, very economic. This is from a paper from Ken Sorby. And if you look at the 3 columns, these are 3 different mobility ratios. So the first one equates to kind of water. The second one equates to a light polymer. And the third column is a heavier polymer. And then if you go down, these are time lapses. And you can see what happens if you first inject your polymer in a heavier oil. And then let's say a low concentration polymer and a higher concentration polymer. I'd like to point your attention to the 3 lowermost blocks in the slide. And what you see there is that the actual timing of the water breakthrough on all 3 is kind of similar. The pure water breaks through a little bit easier, but it's not that much of a difference. The big difference is in the sideways fingering of the polymer. So what happens is the polymer or actually makes the fingers wider, thicker, instead of the thinner. And that is the effect you see with the polymer injection as well. So it's not like a lot of people think it's like a piston, which just pushes everything in front of it. That's not what's happening. It's actually you make your fingers thicker inside your reservoir, and that's what we see. On top of this, of course, you have an effect of heterogeneity. So if you have a heterogeneous reservoir, the water will always go through the easiest path. And because of a difference in your mobility ratio, your polymer will also go into the unswept areas. And therefore, we see an increase in recovery factor from a water flood to a polymer flood. Having said that, the time for production takes a little bit longer. We have to all be very cognizant of that a polymer flood, the actual flooding takes just a little bit longer. So we talked a little bit earlier about the modular systems there are. This is in Argentina. Argentina has come up in polymer flooding tremendously in the last 5 years. And they are at the moment our second biggest area, country, after India, basically. What they do there is they have modules of installations and they move them around in their fields every 2 years. So they move the module from well pad to another well pad every 2 years. Some of these modules are huge and some of them are smaller, but all of them are mobile. I think in India, the potential for EOR in general is huge, but also with a lot of smaller fields you have over here, and especially with the modular systems, I think that is something to explore for these smaller fields. So we've been building those modular systems for over 25 years now. We're on version 14. So version 13 has solar panels on the roof. So we can throw everything you want in there, solar panels and other things. So this is a modular system. I'll show you the next system, which is in Oman, which of course is equivalent to an early Cairn system. So Cairn has the upgraded version of the centralized facilities, and it's also much bigger. This was only 29 wells. So this was our first one. So just to give you a difference, a comparison in the size of the operations if you go central and if you go modular. At the moment, I am working with clients in Suriname, which is in South America, and in Thailand, PTTEP. And all of them are at the point where they just finished their pilots and they're going now full field. And we're sitting around the table to go like, what are we going to do? Are we going to go modular or are we going to go centralized facilities? And funnily enough, that is very much dependent on your flow lines and on your water. So where you have your water available and what is the cost of getting your flow lines through your operations. Are you in a densely populated area? Are you in a vast desert? The desert is easy to get your flow lines in. If you're densely populated area or in a jungle, it's much more difficult. So we're now at that level of, okay, we've done the pilots, we're going full field, now let's do these full field, tackle these full field problems. So that is now what the industry outside India is busy with, but also know that inside India, you're also working on the same issues. I like to get one step further, and this is actually one of my biggest passions, reducing the CO2 footprint of the oil production operations. So yes, we're producing oil, and oils are being used, you know, in your cars and other things here. By the way, one thing you should not forget is that 40% of the oil that's being produced in the world is used for petrochemical industry to create things, so it doesn't get burned. And when somebody says, oh, we only have a 20-year horizon, that person doesn't take into account that we will always keep on producing plastics and other things from oil. So oil is also used as a base material for a lot of products, and that will always go on. So what I'm now talking about is the reduction of CO2 footprint and the greenhouse gas emissions in the oil field operations itself. There was earlier an example from ONGC on one of your successful polymer floods. And you said there that you went from a 91% water cut to a 71% water cut, and that's exactly this example you see over here. So what does a 90% water cut means? It's 1 barrel of oil, and for your injection you need 10 barrels of water, and for your production you produce 9 barrels of water. So, you know, that's quite a lot of energy, so you're pumping up water. So, ladies and gentlemen, I congratulate you. You are all water producers. Because, let's face it, you produce water. There's a little bit oil on top. If you get it down, as in the earlier example, to 70%, that means that for every 1 barrel of oil, you only inject 3.3% barrels of water, and you only produce 2.66667 barrels of water. That difference per barrel of oil is huge, but we don't calculate that because we look at the percentages, and that's actually a wrong way of looking at it because we're only interested in the barrel of oil. So, how to reduce that is basically accelerating your oil, getting the oil up front, and produce less water. So that's my plea to the industry at large, and I've said it in many other conferences and conclaves. Can we please stop producing water? And then people, no, but I re-inject it. So yeah, exactly. It doesn't help. It doesn't help. So the way we're looking at the systems, and we do these analysis, and we did also one of Mangala, is we look, okay, sure, a polymer flood adds an additional pump to the system, a polymer slicing unit to the system, and yes, the polymer itself has a carbon footprint. But that carbon footprint of the polymer is offset by the reduction in oil field chemicals. It's very funny. If you accelerate your production from 10 years to 5 years, that means you also have 5 years fewer production chemicals needed. So that offset is actually takes care of the polymer footprint, which by the way is very little. Polymer is quite simple to make. You add two things together, you shake it, and then you sell it. So having said that, looking at several examples around the world, this is one of the papers we've been writing. We wrote 3 or 4 papers on that. And what you can see is that the polymer flood reduces the carbon footprint either in half or even to 60 or sometimes 80%, depending on the efficiency of your polymer and depending on the change in the water production. So I want to kind of wrap this up a little bit and saying that, okay, so polymer is proven, and by the way, I'm speaking here to the converted because you're all using it already. Like I said, you are ahead of the world here. It accelerates the oil by optimizing your mobility ratio. Easy to implement. Think about the modular systems for the small opportunities you have and move them around. I think that's a big one. The other big one is the CO2 reduction due to the reduction in water production. And what I'm doing right now is we're evaluating a lot of the water floods, and so far every water flood I looked at is actually a candidate for a polymer flood. We're injecting polymer at this moment in 10 millidarcy sands in Thailand. It's not much, but we're injecting it in there. I would not do a full field on that one, but if an area of a field has those kind of properties, it can still be in the mix. And remember, it's just a viscous water flood. It's nothing more than that. You know, it is not rocket science or brain surgery. And the other thing is, you know, it's always a great time to do a pilot, but that's just my view. So thank you so much for your attention.